Yes, so in this short section, I'll introduce a few terms and some basic vocabulary that I think is relevant for people who would like to efficiently follow and understand the concepts that we present in this course. Those three words that I'll just introduce is words that I tend to use very frequently with even not thinking much about it, and sometimes I'm sorry for that. And it's also three words that I remember from my days when learning about this for the first time. Could take me a little bit off guard, and I typically view these concepts as a little bit abstract, and to be actually able to follow a explanation, to actually at least have some basic understanding of what these things are and means, it's important that we've actually introduced them. These words are probably maybe a little bit advanced for a lot of the discussions that we'll go through in this course. We'll touch upon some of them more later in the course, but I'll introduce them now in the beginning anyway. The words are composition, flash, and k-values. So a composition is simply, in this context, referring to the amount of different components that makes up a fluid mixture. Okay, and essentially what it's trying to represent is, okay, what is actually different between a dry gas reservoir, a volatile oil reservoir, a black oil reservoir, a dead oil, a high viscosity oil, etc. And the way we express that is in terms of mole percentage. Okay, so a composition is just describing the amount of different components, and I've witnessed it sometimes myself that if you don't have a good understanding of what a composition is and means, some people can be a little bit caught off guard when they hear that word. And if I use that, I'm just simply talking about the amount of different components that makes up a mixture. Trying to relate this to day-to-day life, we know that air has a composition is composed of nitrogen, oxygen, maybe something else, and it totals up to 100%. Sparkling water, we know, contains mostly water, a little bit of CO2, and it also adds up to 100%. And the same goes for petroleum fluids, the only difference being that petroleum fluids typically is made up of thousands and thousands of isomers, especially if you're working with a black oil, where you have a lot of components that are heavier than C7+. Of course, you also typically have these non-hydrocarbons that we'll talk about a little bit later. Flash, in its strictest sense, a two-phase isothermal flash calculation, are used for processes with vapor-liquid equilibrium. So when I'm talking about a flash, I'm most of the times actually talking and referring to this particular calculation. That is one of the last topics we'll cover in this course. And a flash takes a seed or a feed stream composition and it separates into a vapor and liquid phases, or it remains single phase. So many times if I say we took we produced that field and we flashed it to the surface, and we got a separator gas and a separator oil, for instance, then I'm really talking about this particular process where a total composition partitions into different phases or remains single phase depending on the conditions, and the conditions here being temperature and pressure. The last thing that we'll talk about, and we'll also touch base on that much more later in the course because it's so fundamental for a lot of the understanding related to PVT, is k-values. K-values is just a ratio of the components that has a preference of being in the gas phase and compare it to the component that has a preference of being in the oil phase. The ratio is simply just taking the component, the mole percentage of a component that would like to be in the vapor phase, and you divide that by the the amount or the composition that is in the oil phase, and you get a number. And if that number is higher than 1, the relative preference is to be in a gas phase, and if the number is less than 1, the relative preference is to be in an oil phase. Very, very straightforward.